Ladies and gentlemen, thank you for joining us today. It is my distinct pleasure to introduce to you Dr. Ivo Dinov, truly a scholar and a gentleman. I know Ivo very well. He teaches statistics at the University of California, Los Angeles, that's UCLA, where he is also responsible for the Center for Computational Biology. In addition, and in my view more importantly, he's the driving force behind the Statistics Online Computational Resource, commonly known by its acronym SOCR, pronounced SOCR. In my opinion, its creation is a landmark accomplishment and a milestone in advancing statistics education. It is an invaluable online teaching resource that is currently facilitating learning statistics for students all over the world. And I predict that this will continue to expand, that as SOCR is developed through Dr. Dinov's creative imagination and entrepreneurial drive, that it will make an unsurpassed contribution to statistics education. Ivo, please tell us about interactive web-based probability and statistics using SOCR.
Thank you, Paul. That sounded a little bit more ambitious introduction than it actually is, but I appreciate it. So what I'd like to do now is switch to a browser. Can everybody see, or somebody confirm that you actually can see my browser now?
We can see it now.
Okay. So perhaps in the little chat window, I already have my browser open. So if I go to socr.ucla.edu, this is the main page that you see. For some people that either have slow connection, it might be easier to follow up by just cutting and pasting these links in your own browser as opposed to following everything. Can everybody read the text? Is it large enough font, or do I need to make the font a little bit bigger?
It's fine for me.
Okay. Well, let me tell you a little bit about what SOCR is all about. We started in about 2002 or so, and under the acknowledgements, you can see that we have been funded by the National Institutes of Health and the National Science Foundation. There's a large number of investigators that have helped develop this resource, including faculty, graduate and undergraduate students, researchers at UCLA and other venues, and so forth. I believe one of the main components of SOCR is that it allows us to do 4 types of resources. The first one is data, second one is methods, the third one is demonstrations, interactive demonstrations, and the last one is tools. So I'm going to, again, kind of push these things here so that we can keep track of these 4 things, because I'm going to be stressing over and over again these 4 concepts, how they are integrated through SOCR. Now, if you're interested in, I would recommend you go to the About SOCR box and click on this little link here on the top that says Geomap. This allows you to see where SOCR is located, number 1, of course, on the UCLA campus, as well as track the users of SOCR for the past 24 hours. This is an interactive Google map that allows you to see the users that we've seen from the United States as well as across the globe. Clicking on any one of those is going to tell you the city that they come from. The SOCR has produced one resource which we call the ebook, which is probably the first complete interactive textbook on probability and statistics education. I want to push that link as well to all of you if anybody wants to follow up. So let me just show you what this is. If you go to the ebook page, I'm pasting the link on my browser URL address bar. All of the wiki pages that I'm going to show you always start with a table of contents, which you can hide if you want. So you can see how I'm hiding or expanding the table of contents. Now, I do understand that this is a primarily middle and high school statistics and mathematics instructors that have joined us. Many of these materials may be a little too advanced for your students. However, concepts, examples, data, and tools that are illustrated in this textbook may be quite applicable to much of what you're presenting in elementary classes. So for those of you that are interested in activities, various events that SOCR is engaged in, again, if you go to the SOCR main page, on the very top left corner, there is a link for the events, news, etc. That simply has a link of chronological year by year venues that we have presented SOCR at, various awards that were awarded to SOCR, and seminars that we sponsor, and demonstrations that we do. With that introduction, perhaps I would like to stress two things which are very important. The first one is that none of the resources that I'm going to be showing today are considered to be one-size-fits-all. These are simply materials, tools, and infrastructure that we provide for instructors to build their own course curricula tailored for their specific students. So I don't mean to imply that all of the tools or any of these tools that I'm going to present, you need to exactly replicate the same things in your classes. We are simply trying to provide the infrastructure for you to develop educational materials. The second thing that I want to stress out is that all of these materials that we'll show you are open source in terms of their development and in their usage. There is no special account to be created. There is no special software to install. There is no registration. These are open to the entire community and can be accessed all the times. So coming back to the big four that I mentioned a second ago, I want to point you to the first link, namely on data. So I'm going to push that again to all of you and then paste it in my own browser. Okay, so does everybody see what I'm doing here?
Yep.
So I'm going to the SOCR data resource. There is a large collection of data sets that we have pre-selected, and we continue to expand on that allow you to use as motivation for various concepts or to demonstrate use of various tools and resources. I'm certainly not going to go over all of these things, but there is a climate change data, there is human weight versus height, a very large collection of data sets, 25,000 records. Of course, in demonstrations, you may want to copy and paste all of this data into one of the SOCR charts and plot all of them, but most of the time you want to kind of copy a small collection, sub-part of it, and then use it as a demonstration. There is economics data, consumer price index data, there is earthquakes data, very interesting. Some of you might be interested in that for the reason that in addition to actually having the raw data, we actually have a geomap that shows you where are those earthquakes, where have those earthquakes occurred. So again, this simply uses Google Maps. It has every single earthquake that has occurred in essentially California, San Andreas Fault, going all the way up down from San Diego up to Northern California. And if you click on the data, you see we have magnitudes, and these are only the big earthquakes. These are not certainly all earthquakes. These are magnitude 5 or bigger, I believe. It reports for you latitude and longitude. It reports a number of other characteristics, the depth of the earthquake, etc. It can be used for various demonstrations. There is also a data set for advanced placement scores that you can see up here by discipline, etc. Some people may be interested in that. There is a very interesting data set on mercury and fish contamination, basically. There is a large data set that comes primarily from my research on Alzheimer's disease that integrates neuroimaging and neurobehavioral data on a large number of subjects. And there is one more daily kind of use of hot dogs, calories versus sodium data set. So this is the first type of thing. Methods, under methods, is essentially everything that we had underneath the ebook. So let me push that again. So that's the second major concept. What are the methodologies for for studying various statistical concepts. So you go to the ebook, and for example, you can do a search here. If I do Control F on my browser, I don't know if the pop-up window appears. Does a pop-up window appear on everybody's screen?
Yes, it does.
Okay. So and I type something like limit for central limit theorem. You see, I can go ahead and get directly to the central limit theorem, and it opens up, of course, the chapter that this is part of, namely chapter on the relations between distributions, and you can go to the central limit theorem and kind of browse deeper and deeper into that archive for the tools that are demonstrated in this concept. So I'll get back to some of these and illustrate specifically. Demonstration activities. We have a very large number of demonstration activities for different concepts. Let me push that to everybody again. Okay. So these activities are of different types. We separated the activities by distributional activities, experimental activities, analysis activities for statistical analysis, various virtual games activities, modeling activities, plotting and exploratory data analysis, EDA, as well as various general activities. I will demonstrate some of these as we go along. Tools is the last concept that I kind of stressed initially. Let me give you that link explicitly again so that everybody has it. And I'll just show you one of the examples of tools that we have. Something called something called SOCR analysis. We have probably the largest collection of statistical analyses that are publicly available using the same interface. There are parametric and non-parametric analyses, univariate and multivariate analysis, and a variety of other things. And just to kind of show you one example, you can choose any of these, like multiple linear regression. If you don't have any data, you can select one of the examples data that we provide for each of these things. I hope everybody kind of can see the data kind of appearing magically here in my data window. And then as soon as you have your own data, or perhaps it's better to demonstrate with real data, no? So why don't we demonstrate that with real data? So if I go to my wiki page, and I'm just going to go to the educational materials and go back to the data link. And now why don't we get the hot dogs, calories versus sodium data set. So you see what I can do here is I can grab with my mouse this table, Control C to copy it, go back to my analysis, remove everything, clear, and then just paste in. Here is the paste button. Paste this data in. Now, in this case, I need to tell the computer, and this resource, which variable is dependent and which is independent. So if I go to the mapping tab, I can say column 2, for example, is the dependent variable, column 3 is the independent variable, and as soon as you map them, you click on this button here that says calculate, and the results are going to be reported in the results tab. If there are any graphs that are appropriate for that type of analysis, they'll be plotted right up here. So you can see, for example, this is a scatter plot of the calories versus sodium content of these 54 hot dogs. Later, we also have, anytime you do a regression, you have residuals. Here are the residuals. Do they show a pattern to indicate that perhaps a linear model was not appropriate in this case? And here is a QQ normal plot of the residuals to indicate that perhaps the model is not that bad. So this is just one demonstration that shows you what do we mean by the integrated nature of data, methods, tools, and materials. Coming back to our discussion here, now I want to show you the link that was specifically designed for this specific webinar. So I'm going to get this link. I just pushed it to everybody, and I'm going to paste it in my web browser. This is, again, a special web page that we designed for this specific webinar. It has some of the logistics on the top here that you can see. But now what I would like to do is perhaps ask you to try to follow up with me and do some activities on your own and see what works and what doesn't perhaps in your settings. Now, I do need to say that all these activities and tools do require Java-enabled browsers. Most modern computers and most modern browsers that are, at least a version that was designed in the past 3 years will be okay by default. But about 1% or so of our users I know have difficulties with some of the applets, either because they're staying behind a firewall or some other program disables their Java applications. So there is nothing that SOCR or anybody else outside of your own domain or system administrator can do to fix that problem for you. So what we did to prepare for this webinar is we essentially took the State of Utah's core curriculum on standards for statistics, which is pointed to right here at the bottom. You can see the PDF file by clicking on it. So we looked at this document and discovered exactly the types of objectives and activities that a typical probability and statistics or quantitative curriculum in some of the middle schools may engage in. So let's just go to the first link. Use of basic concepts of probability to determine the likelihood of event and compare results of various experiments. So if you click on this link, it opens a brand new page for us that gives you directions of what to do to see some examples for that specific objective. So the first thing that it says here on the top is go to SOCR experiments, select the dice experiment from the top-down list of experiments, and choose the number of dice. So why don't we do that? So what I'm going to do now is I'm going to right-click, and this is going to allow me, it is going to allow me to open the new link in a different tab so that I can switch between tabs. Does everybody see my tabs here on the top? So I was in this tab here, and here is the new tab that was just opened up for me. I need to go to the dice activity. If you just type a D here, it's going to go to the first activity that starts with a D. There is a number of them, but the first one is the dice activity. And then again, coming back, perhaps I'll just kill some of these over there next to each other. We'll keep that. So it says select the number of dice equal to 1, which is the default case, as you can see up here. Right? I can put in more dice if I wanted to. And then the instructions say run the experiment several times by clicking the step or run button. So that's what we're going to do here. We're going to, if I click once, just a single dice rolled once, and I got a 6. If I click twice, there is another experiment. And I'll notice what happens in this graphing panel here on the top right. On the top right, I have a blue curve that gives me the theoretical probability distribution of observing a 1, a 2, a 3, a 4, a 5, or a 6 as an outcome of rolling this die. The red histogram, on the other hand side, gives me the sample frequencies for each of these outcomes. So this second button here, if you bring the mouse over, it says run, does these things a number of times. So the default is 10 times, so if I click run, it's going to do this 10 times. And you see how all the results are being recorded up here. Now, taking this sample, one can hypothesize that this die that we are virtually rolling here is not fair. Certainly 1 and what is this, 4 showed up the most frequently, and 2 or 3 showed up very, very infrequently. However, if we keep running this thing a number of times, we can see how the theoretical and the empirical probabilities approach each other. And then you can actually, once you do this a few times, you can actually do it 1,000 times. And you don't want to see every one, you want to see every 100 update or so. So click run, and now the computer is updating you only every 100 times. It's going to do this 10 times. You can again observe the match, the improvement of the match between the theoretical and the empirical distribution here when the two are superimposed. The last table that's on the bottom here indicates the theoretical distributions and the empirical distributions. It has the theoretical mean, the empirical mean, the theoretical standard deviation, the empirical standard deviation. Now, Once you do that, you may want to say, hey, how about if the die was loaded? Clicking on this little button that has a die on it, you can see how I can actually represent a loaded die. This is a die that's loaded for the low numbers, and the high numbers are less likely to occur. If you click OK, notice how the theoretical distribution changes accordingly. It becomes a stepwise function, because that's how we loaded it. I could have put a load in, let's say, on 6 instead. See, if I do 0.5 here, oops. If I do a 0.5 here, I loaded 6. Right? So 6 is the most frequently occurring observation, and I can do the same thing. Or oftentimes, let me stop that. Oftentimes, you may want to have more than one die. Suppose you've got 10 dice that you want to roll. Okay? Clearly, this experiment is going to be very, very difficult to be performed in class with real dice, because the dice are going to start falling off the table, they're going to start bouncing onto each other, independence assumptions may be violated, etc. Virtually, however, we can do this thing quite well. So this is simply one of the examples that illustrates how do you draw analogies between, again, the theoretical in the second column and the empirical measures. Scrolling down a little bit, this again kind of has a snapshot for each of the things that I just did a minute ago. Now, by the way, you should know that every single image that appears in the SOCR resources is a clickable image. So if you click on it, you will be able to get a higher resolution version of that specific figure that shows you the details. You see, this is a snapshot of what I just did interactively for you. That helps students actually follow up the concept step by step. So coming out of it. Moving forward here, let me show you perhaps another example. This simply says, why don't we go ahead and grab the summary statistics that are reported up here. Let's go ahead and grab these things with the mouse. I'm going to press Control-C, and let's see what the instructions say. The instructions say, go to the SOCR pie chart. So I'm going to right-click here and open this graphing tool in a separate tab. Notice how I have a separate tab that appears here on the top. And the instructions say, why don't you paste it in the pie chart? So why don't I go to Data, select one of the pie charts. There's a large number of charts that we have here you can choose from. I'm going to come back to this later on. It doesn't matter which one you choose. Each one of those tells you something about this data. And I'm going to clear that, let's say. Or instead of clearing, click on the first cell and click Paste. Here is the Paste button. Now, remember what happened now is I grabbed some data that we randomly generated on a computer and I pasted it in a charts plot. So what I need to do now is I need to label various things and update the chart. So here is my chart that I just generated with the outcomes of this specific experiment. Now, obviously, this doesn't make sense here, right? I mean, because, you know, this simply gives me the probabilities. I can visually see which was the number that appeared most frequently. So this was the number right up here, 20. 29 or so. There we go. So I can make inference basically on, is my die appearing to be random based upon these observations? Now, of course, I don't expect it in this case, because if you recall, this was not a fair die. This was a die that was loaded towards 6. So the sum is the variable that we looked at, the sum of the 10 dice. Y is probably going to be slightly different each time we run the experiment. But at any rate, you can see how we can go from a simulation to data to an exploratory data analysis, basically by plotting the data that we generated. So coming back to our activity here, I'm scrolling down. So here is what was done when a single die was rolled. 6 appeared several number of times. Some of the other numbers are also having different frequencies. See, 1 was the most frequently occurring number, followed by 2, 3, 4, 5, and 6. If you have a loaded die. Okay, so let me go back of this first activity, perhaps, and go to the second one. Display and compare data to make predictions or formulate conditions. So again, I am not trying to propose a new curriculum for teaching middle school or high school students. I'm simply trying to provide you with resources and tools that you can use to address these topics. So these are by no means curricula that we're trying to have everybody use. So let's look at the first one. The first one says display data using tables, scatter plots, circle graphs, etc. Well, I mean, you can use each of these blue links here. You can see are links that you can click on and get to a section that expands on that topic. So I don't have, again, the intention of covering all of these things, but perhaps some random ones we can choose. For example, data visualization using frequency tables. If you click on this link, it basically leads you to a new page that defines what frequency distribution is, defines what a relative frequency distribution is. Then it gives an example. It gives an example of breast cancer patients of different stages of the disease. Okay? And now it says, why don't you grab this with the mouse, and that's what I'm going to do. I'm just going to click Control-C for copy this. And it says go to charts, okay, and paste this in the bar chart histogram. So here's my charts. Let's expand it again. Go to the bar charts, histogram, okay. And you can see how this histogram comes in here. I can actually clear that, paste in the data. Remember, this was the data with the cancer patient, so I can actually label each of these columns. This was a stage of the disease, and this was the number of subjects. And if I do the mapping, and click Update Chart, it gives me directly a histogram chart of the stages, of the 5 stages of breast cancer, so that we can visually see, the relative size in addition to the numerics. And of course, if you change any of these things, why don't we kind of make this one 500 so that we can see the actual change, and you update the chart, all of a sudden you can see this thing growing up. So this is a dynamic way, and it also reports for you some summary statistics that may or may not make sense for this specific data type. The summary statistics that we report are essentially various standardized moments, mean, median, standard deviation, etc. So coming back here, there is a number of things, a number of ways that you can do scatter plots. So if I were to click on scatter plots here, it's going to open a new page for me that gives me the instructions of, again, how to go ahead and get some data, where and how to paste it. And remember, I actually had a link to my data. This was the human heights right up here. And now again, as I said, this is over 25,000 records, so it's a very large data collection. It's over 7 megabytes of size. The complete collection you can see up here. We have included a smaller sample that's certainly manageable for calculations of 200 of these things that I can copy and paste. And the instructions here say simply go to the scatter plot chart. And if you ever get lost here, there's a search button, scatter. If you type scatter and search for it, here is 2 things of scatter. So if you go to this chart here, and then you go to the data column. You clear that. You paste in the new data that you just got. And then you have to map, of course, now the weights were in the second column, the heights were in the third column. If you update the chart, you can see visually the obvious trend that we all know how to expect between weights and heights. Higher weights typically indicate higher heights. This, of course, is not a tool for doing analysis. So that's why you don't see here a linear regression model. If you would like to get the linear regression model, then you have to go to the SOCR analysis right up here on the top and actually get the linear regression. It's right up here. You can paste in that very same data in. You see 200 observations. All the way down, you can see the 200 observations. Now remember, the heights and the weights are in the second and third column, not the first column is simply the index. So when I go ahead and say which one is dependent and which one is independent, it's very important that I put in the right columns. You click calculate. The results are right up here for you. And now here is your regression curve. Does this make sense? So now you can see the linear best fit. And again, if you're interested in the exact value of the fit, here is the slope and the intercept of the best linear fit reported for you, as well as various statistics about how likely are these coefficients, namely slope and intercept, to be trivial. In both of these cases, you see the probability that these are trivial are essentially 0, and you can get a better precision here if you'd like, which basically indicates that the intercept of 56, in this case, remember, I fit in, I believe, the second column was heights and weights were in measured in pounds. So you can see these results as well as various statistics that may or may not be interesting for your specific class. Okay. Another way that we can do is we can do a, both of these diagrams here indicate scatter plots of the data against the index, right? This may be of interest to some students, I suppose, if they want to see, well, how are these data actually observed? How about if I wanted to see on the horizontal axis the subject ID, and on the vertical axis I wanted to see either the height or the weight? I can do that as well. And in this case, the first 20 subjects, we have an index plot of their heights and weights, the pairing of the heights and weights. So you can see the increase of heights drives up the weights, and correspondingly decrease of one drives the other one down, because these are very positively correlated. Okay. Now, another little property that I want to mention, and I don't know to what extent this would be useful for your students, but all of the SOCR materials are automatically translated in a number of different languages. This probably would not help many of your students, but some non-native speakers may actually make this may be very great helpful for. So, for example, here is the Spanish translation of that same section that we just went over. If you click here on Spanish, it just leads you directly to an automatically translated version of the same materials. Everything is in Spanish now. So, stepping back a couple of times, I'm going back to the objective. So if you notice, this is back the page that I pushed about 15 minutes ago, if you want to go back to there. Let's look at one elementary probability example, perhaps that may be of relevance to some of the students in middle and high school. Elementary probability example. Suppose you have a situation where you're given 3 different boxes, each of which contains 2 different types of balls, red and green balls. Suppose in the first box, let me make this a little bit bigger. That's probably better visible now. Suppose the first box has 4 red and 3 green balls, and it's kind of indicated here on this figure. The second box has 3 red and 2 green, and the last box has 2 red and 1 green. Again, as before, you can click on this image and actually get a nice higher resolution representation of this image. Coming back out of it. So suppose all the balls are identical except for their labels in terms of their colors. Suppose we draw one ball at random. The questions, there could be several interesting questions, right? Which of the 3 boxes is a red ball most likely to come from? Okay, so you know, what's known is that the ball that was pulled out was red. What's not known is which box it came from. So of course, we all know how to do this thing exactly. You can point out the exact solution of the problem, or you may want to do this thing empirically first. We're going to do both of these things. The exact calculations are simple. You know that for each of the 3 boxes, the probability of drawing a red ball is 4 sevens for box 1, because there is 4 out of 7 are red, 3/5, and 2/3. Now notice that these numbers are on purpose, the dividers are on purpose prime, so that it's not really clear which one is bigger, 2/3 or 3/5. One needs to find the common denominator and then proceed, right? So at some point, some calculations will be needed by the students. It's not empirically clear which box is most likely to produce a red ball, because all 3 of them have red balls, and the proportions are fairly close to each other, right? About a half. Slightly bigger than a half, right? So you can find the smallest common denominator, which is the product of these 3 prime numbers, which is 105. Very odd number, it's not something, it's not 100, it's not 10. So these probabilities may be expressed correspondingly using the common denominator into 60 105s, 63 105s, or 70 105s. So at this point now, it should be clear to every student that the last box is the most likely one to generate the red ball, because the probability of red ball there is the highest. So again, this requires a very simple calculation, but may be appropriate for many people. Now, on the other hand side, you can do this thing empirically. So you can use the SOCR bow and urn experiment. If we go back to our SOCR experiments and select the bow and urn experiment. Okay. Now, for each of these, remember, the first urn contained 7 balls. How many of those were red? 4. How many do I want to sample? Suppose I want to sample 1. Do I sample with or without replacement? Let's say I can sample 1 ball, perhaps, and it's going to be either red or green, right? Now notice how the theoretical distribution tells me right away that the probability of drawing a red ball, this little R here stands for red, is slightly bigger than drawing a green ball. But I can do this thing 1,000 times and actually imagine the probability was not given to me. I can do this thing 1,000 times and simply look at the empirical distribution down here. How many of these draws generated a red or a green ball? So you can see 56.8% of all draws generated red ball, and the theoretical was 57%. And the corresponding for the green one, we have an analogy between the theoretical and the empirical distribution. So once the students have worked that out for the first box, they call it the second box contained slightly different. The second box had 3 out of 5. So you can change this to 5, and 3 of these are only red. You do the experiment again. You run and observe the empirical and theoretical probabilities. And now, we all should acknowledge here that there is a little bit of danger that there is a chance that things are going to be kind of misinterpreted in a way. But you can always see the correspondence between what we had before and what you observed for the second error. And for the last one, there were only 3 balls, and 2 of them were red. You can do the same thing and kind of find empirically which one is most likely to generate a red ball without, or perhaps validating if you want, the theoretical calculation, the exact calculation that we saw a minute ago. Or you can do this thing by selecting a larger number of balls. So in these snapshots that I included here, you see, I had selected n to be 100, and I simply sampled with replacement. Notice how this activity allows you to sample with or without replacement. If I sample without replacement, obviously, I can go to a large number of balls. If I sample with replacement, without replacement, obviously I cannot exceed the number of balls that are in the urn, right? So the applet prevents you from going to 100. So I know I have only about 5 minutes or so, so let me go back to the objectives and see what would be perhaps of most interest to most of you guys. There is a section that covers percentiles, quartiles, graphical summaries of histograms, box and whisker plots, very, very commonly used indeed. They're also available under the SOCR charts. You can see them right up here if you do a search and type box or whisker. You can see there is 3 different versions of the box and whisker plot. Anytime you don't know how the data is entered, you click on the Show All button, and it shows you the graph. It shows you how the data is entered, shows you the mapping. Again, the mapping tells you which column corresponds to what, which column contains the series, which column contains the categories. For any of these charts, there are a number of charts. There is over 70 different types of charts here. Some of them are interesting, like the spiderweb chart, because they show you relation in the direction of various categories of multiple series. The red, green, and blue colors here are multiple series, you see. First, second, third, etc. Many of the line charts would also be of interest. There is a dot chart. This is a very commonly one used, followed immediately by a box and whisker on the bottom. And of course, it contains the summaries. The summaries are right up here of your data. So in addition to getting the visual representation of your data, you can actually see some of the summary statistics. Again, the data is simply entered one at a time in this case. If you have bivariate data, bivariate data, just like we looked a minute ago at the height versus weight. There is a number of different ways that you can visualize these types of data. So here is one example that I put together again using the height and weight data set. In this case, I simply used the scatter chart, as you can see, but I also gave you links here to estimating the intercept, just like we did a minute ago, the best linear fit to the data, conjectures about the data, interpreting the slope, predicting the values for x for a given value of y. So there are some activities here. In terms of basic application of basic concepts in probability, I believe the curriculum discusses permutations and combinations. Many of these things are available in various forms. For example, there is a simulation activity that we can go to by clicking on this link. Why don't we cover this one and see if that will be of interest. Suppose this is a very common problem in science, actually. Suppose we have this image, and I'm trying to estimate the area of the purple region. One way that you can do that is you can toss darts at this board and basically count the proportion of darts that landed in the region of interest. That proportion is going to be approximately the relative area of the purple region to the square that the region is embedded in. Does it make sense? So this is a very, very common problem in a number of scientific applications. To estimate the region volume or area, in this case, when the boundary of the region is not given in closed form using an analytical expression. Obviously, there is nothing to integrate because I don't know what the boundary is. So in this case, we've tossed 15 different darts. 7 of these guys landed in the area of interest. So we can say that, hey, empirically, the probability of the area can be estimated to be 7/15. Again, there is example with coins, with cards. If you emphasize more, card games or various other things, we have worked out the probabilities for all of these different events that come into play in poker, explicitly in terms of combinations and permutations. And you can see hands-on how these things come into play when you go to the card experiment. Pardon me. So go back to the experiments and select either the poker or the card experiment. There is a card and there is a poker experiment. Right up here. That you can run again. The computer generates random cards. The distribution of various events is recorded. And you can validate, again, empirically, some of the theoretical probabilities that you can compute exactly. That may be of interest. Another point of interest is the roulette wheel. I like to use this as an example in my classes quite often for the following reason. We have a roulette experiment here. However, it does not allow me, you can see the die kind of moving about, but what I'd like to show people is how you can actually load the roulette game. And many people kind of relate, students typically like to see how do you load, so that one number is more likely to turn up. This is achieved by going to the spinner experiment. You select the roulette, has 38 different slots. And if you click on this little button here, it allows you to change the probabilities of each of these guys. So for example, if I wanted to make 23 the most likely number, I can do that. And look what happens. Here's my 23. Does everybody see the loading? Now, obviously, this loads and shows me the area in terms of the proportion. However, in reality, the space occupied by this number 23 is going to be the same. And of course, you run the experiment, and the little spinner kind of models the dime, the little ball that spins around. So you can see we've got 2 out of 2 ending up in the region of interest. That's a popular experiment that students can relate to. I perhaps would like to stop here and leave a few minutes for questions, comments, suggestions, ideas from the audience, if I may.
Thank you, Ivo. Let's do that.
Does anybody have a question of the type, how would you demonstrate X? Or do you have data or materials for Y? Or wouldn't it be better to do this thing the other way? Any comments or questions would be quite welcome. While perhaps people consider that, I would like to show you how you would find SOCR materials.
Yeah.
Go to the SOCR homepage and click on this little dynamic figure here. It shows you the hyperbolic graph viewer. Here, this is an interactive way that you can find this event, for example, May. I'm going to type May. May, and I'm going to cycle through May. Oh wait, this is not entered yet online. However, it will be. Here is an event that we held at the ASCOT last year. If you double click on this event, it points you directly to the web page that we designed for that specific event. If you search, for example, for dice, here is chi-square die experiment, coin die experiment. You can search for more experiments. You can look for poker dice distribution. Does everybody see how this shows you visually? And again, clicking or double-clicking on any of these things would open the resource for you in a separate page.
Actually, Ivo, let me tell you, that is my favorite part of SOCR. SOCR is fabulous, but that diagram that you use there, that interactive diagram to find things, that I think is just marvelous.
Thank you both. So, questions, comments again from the audience?
There's a lot to digest.
Pardon me?
So there's a lot to digest.
Oh, certainly. Right.
Yes, it is.
But again, I would like to stress that we don't have any intention of telling you how to conduct your classes. We're just providing tools that may, under certain circumstances, be appropriate for your classes.
Mm-hmm. Ivo, would you review one more time the links that you provided, how our participants can find those links?
Absolutely. So there is two ways to get there. So suppose I start with a fresh browser. I just type in SOCR.ucla.edu for Statistics Online Computational Resource .ucla.edu, and I hit enter. Now this gives you the main page for SOCR. You can see the about, SOCR, education with used SOCR offline, and you can download it. You can use it offline on your computer. But if you go to SOCR News and Events, right up here, News and Events, under May 5th, you can see the link that I just showed you a minute ago. And as soon as you get there, you can actually traverse each of the sections that I showed you a minute ago. Each of the sections you can get to from there. Does it make sense?
Yeah.
All right. Well, I know it's 3 o'clock, so people will probably start disappearing here. Feel free to send me any comments via email, dinov@UCLA, dinov@ucla.edu, if you have any. I appreciate your invitation, Paul, Rick, and Rebecca. It was a great pleasure.
All right. Well, ladies and gentlemen, thank you for joining us today. I'm sure that after seeing what you can do with SOCR, you agree with me that SOCR is an unprecedented resource for teaching and learning statistics. And best of all, you get all of this is freely available. Ivo, thank you for creating SOCR and for sharing with us today the capabilities of SOCR. Thank you also for showing us how we can use SOCR in support of the Utah State Education Standards. Now, our next webinar is next Wednesday, May the 14th, when our topic will be Math is Music, Statistics is Literature, presented by Dr. Richard DeVoe. So please mark your calendars, and we will see you all then. Thank you.
Thank you.
Thank you.